Number 8 says, if a sheet of aluminum foil with a density of 2.7 grams per centimeter cubed, right? Remember, we also have to remember a centimeter cubed is the same thing as a milliliter, right? So keep that in the back of your head. We're not going to use that for this problem, but keep that in the back of your head. It weighs 6.45 pounds and has a thickness of 0.0210 millimeters. The surface area of the foil is closest to what? Okay, so first off, we have to know the difference between surface area and volume. So here I have this book. If you see, the book has a width and a length, right? A length and a width. That is what makes the surface area. When I add a thickness to the book, now I have a volume, okay? So you want to keep that in mind. You have a surface area, which is just the length and the width multiplied, but now when I add a thickness, now I've got a volume, right? Now I can occupy space. So keep that in the back of your mind. So we know it weighs 6.45 pounds, and it has a thickness of 0.0210 millimeters, right? So if I know the weight, using the density I can find the volume, and if I know the volume and I know the thickness, I can divide those two to find the surface area. Okay, remember, volume is just length times width times height. So if I can kind of find the volume and I can divide one of those three aspects off, I can get the surface area, which I can divide by the thickness and get the surface area. So that's our thought process for this question. So we're going to start with that 6.45 pounds. Because remember, we're going to go to volume, and our mass is our conversion factor from with the density. So we have 6.45 pounds. So we have to know a little conversion here. It should be on the back of your periodic table of elements. You should have that conversion factor, so you don't have to know the conversion between pounds and grams. I have it here is 2.205 pounds for every 1,000 grams. Okay, so now I'm in grams. Good, so now I can use my density conversion factor. I know for every 2.7 grams, I have 1 centimeter cubed. Okay? So pounds cancels, grams cancels, I'm in centimeters cubed. And this is 1083 centimeters cubed. Remember, I have centimeters cubed, which is centimeters times centimeters times centimeters, which is a volume. This is a volume. So if I have a volume, and I want a surface area, well, I just need to divide by the thickness. Well, I have the thickness. They gave it to me, but they gave it to me in millimeters. So I'm going to want to convert that. So you can convert this to millimeters, or you can convert the millimeters to centimeters. You just need to be in the same units. So I'm going to convert the millimeters of the thickness to centimeters. So I have 0.0210 millimeters. So to go to centimeters, what I usually do is, so I don't trick myself, I know you can go straight from millimeters to centimeters. I go to meters, and then I go to centimeters. So whichever way works best for you. This way I know for sure I'm not going to mess up. So I know there's 1,000 millimeters in 1 meter. And I know in every 1 meter is 100 centimeters. Millimeters are canceled, meters are canceled, and you'll be centimeters. So we just moved it by 1 decimal place, so we get 0.0021 centimeters. Okay? So now I have centimeter thickness, this is the thickness. That's my thickness, and that's my volume. So if I get my volume and divide it by my thickness, centimeters cubed, divided by my 0.0021 centimeters, that should give me something squared, which is starting to look a lot better. Now we're looking like we're in surface area dimensions. So if you actually do this math, you'll see this will cancel, that'll cancel, and we will get 515714 centimeters squared. Okay, so that's technically not the wrong answer. I mean, it's technically not the right answer, but it's not wrong either. That is the correct answer. It's just in centimeters squared. They want the answer in feet squared. So we got to do one more conversion. So this question is a lot of conversions, but it's good practice. Okay. So I know another conversion that you don't need to know. So how do I get to feet? Well, I get to feet from inches, and then I get from inches from centimeters. So you don't need to know this conversion either. It's going to be on your periodic table. So I know there's 2.54 centimeters in 1 inch. But now we got a little problem. We have a centimeter squared here, and we only have a centimeter here. Well, the way we correct this problem is we square our entire thing. Because now that gives me centimeters squared and inches squared. So centimeter squared cancels with centimeter squared. And now I want my answer in feet squared. Well, we know, if you've ever been to Subway, there's 12 inches and 1 foot. Again, though, I'm in inches squared, so I need to square this whole thing. And when I mean square the whole thing is, I mean you're going to divide this number by that number squared, and then divide it by 12 squared, right? So if you go ahead and you do all that math, you will get, wait, I didn't, so this will cancel here. You'll be left in feet. So you should get approximately 555 feet squared, or answer choice number 5. And that's number 8, guys.
The Teaching Center, UF's Learning Resource Center.